If you look at the national weather map today, like today, August 9, 2026, it doesn't really look like nature doing its usual, complicated dance.
No, not at all. It's a mess out there.
It really is. It looks more like a thermal image of a highly stressed engine that is just running entirely in the red.
Right. The whole system is redlining.
Exactly. I mean, we are looking at a planetary machine pushed to its absolute physical limits. And that is our mission for this deep dive.
We've got a lot of ground to cover.
We really do. We're going to map out these extreme and, well, highly interconnected weather patterns gripping the United States today. We are talking about a relentless western heat dome, massive wildfires, stifling southern humidity, and just these explosive East Coast storms.
Which are all feeding into each other, by the way.
Right. So whether you are traveling this weekend, or maybe you're checking in on family across the country, or you just want to understand the sheer scale of the atmospheric forces right outside your window, we are going to break down exactly what you need to know without all the information overload.
Because what's fascinating here is that we aren't just looking at isolated local forecasts, but massive continent-spanning systems.
It's all connected.
Exactly. The pressure systems out west are currently dictating the air quality in the Midwest.
Which is wild to think about.
It is. And the atmospheric flow out of the Gulf of Mexico is actively determining the safety of the afternoon commute on the East Coast.
Okay, let's unpack this. To understand this stressed engine, we really have to start where the heat is the most punishing and dangerous, right? The desert Southwest.
Yeah, that's the primary driver right now.
I mean, looking at the data for today, Las Vegas is hitting 114 degrees, which is pushing dangerously close to its all-time record of 116.
And they have an extreme heat warning in full effect.
Yeah, and it's everywhere down there. Yuma's at 113, Lake Havasu is at 115, and Phoenix is sitting at 112 to 114 degrees with a relentlessly clear sky.
The National Weather Service is explicitly warning that without intervention, things like heat cramps and exhaustion can quickly escalate to heat stroke.
Just in a matter of hours, right?
Exactly. Clark County actually has cooling stations open across the area just to keep people safe.
But the detail that really stuck with me, the thing that makes this so dangerous, is that Phoenix's overnight lows are barely dipping into the low 90s.
The lack of overnight cooling is the real killer here.
It kind of reminds me of a smartphone battery. Like, you use it all day, running heavy apps, and it gets super hot. But instead of plugging it in overnight and letting it cool down, you just leave it running.
And eventually it just overheats and shuts down entirely.
Right. The system fails.
That is a perfect analogy, because human bodies have that exact same design limitation. We absolutely require a recovery window at night.
But when it's 92 degrees at 3 a.m.?
That window slams shut. Your heart is working overtime all day to pump blood to your skin, trying to radiate heat away. When the ambient temperature doesn't drop, your internal engine never gets to idle.
That is terrifying.
It is. It stresses human bodies, but it also stresses local infrastructure.
Right.
And this is all being caused by the mechanics of a massive heat dome. We've got this ridge of high pressure extending all the way up to Denver, by the way.
Wait, Denver? Up in the mountains?
Yeah, they are nearing 100 degrees today.
Oh, wow.
And in atmospheric physics, high pressure means sinking air. As millions of tons of air sink toward the surface, it physically compresses. And basic thermodynamics dictates that compressed gas generates friction and heat.
So the atmosphere itself is actively superheating the air as it pushes it down.
Exactly. And this intense dry heat doesn't just bake the desert, it actually acts as a giant kiln for the forests up in the Pacific Northwest, which creates our next massive issue.
Right, the wildfires. Because the fallout up there is just staggering. Over 2 million acres have already burned in Oregon alone.
It's an absolute tinderbox.
Yeah, looking at the feeds, Portland is at 88 degrees and completely dry. Boise is sitting at 92 degrees surrounded by red flag warnings.
And Spokane is dealing with severe smoke from a really destructive fire on the city's north side.
But here's the piece of data that really tripped me up. Seattle is sitting at 82 degrees and is only just now starting to see smoke after avoiding it basically all summer.
Right.
But at the exact same time, haze from those Oregon fires is being reported all the way out in Fargo, North Dakota, which is also at 82 degrees.
Yeah, the Midwest is definitely feeling it.
So wait, how is it that Seattle managed to avoid the smoke for most of the summer, yet the haze from Oregon fires is currently being reported all the way out in Fargo, North Dakota?
That is a really great question. You have to remember that the atmosphere operates in 3 dimensions.
Right, it's not just a flat map.
Exactly. For most of the summer, Seattle was protected by its low-level marine air pushing in off the cold Pacific. It basically acts like a fan, blowing surface-level smoke inland.
But the fires in Oregon are super intense right now.
Extremely intense. They are pumping massive plumes of smoke high into the stratosphere, punching right through that shallow marine layer.
Oh, so the smoke goes up and over the coastal protection.
Yes, and once those particulates get 20,000 to 30,000 feet up, they get caught in the upper-level winds, specifically the jet stream.
Which is like a transcontinental conveyor belt, right?
You hit the nail on the head. And because that massive high-pressure heat dome is dominating the west, the jet stream is forced to flow up and over it, catching the smoke and carrying it thousands of miles across the country.
Directly into the upper Midwest. It just perfectly illustrates how interconnected this whole engine truly is.
It really does.
But, while those upper-level winds are carrying smoke out to the Midwest, closer to the fires, the weather is creating these bizarre, trapped microclimates in California. And here's where it gets really interesting.
California's topography makes things so complicated.
It totally does.
Yeah.
Because the Central Valley is just baking right now. Fresno is at 106 degrees. Redding is approaching 108 under a heat advisory.
Yeah, and AccuWeather is specifically warning about temperature inversions down there, which trap the wildfire smoke super close to the ground and reduce visibility.
Right. But then, less than 60 miles away, San Francisco is locked under a marine layer at a cool 63 degrees.
It's a massive contrast.
It's a 40-plus degree difference in like an hour's drive. It is physically like walking out of a walk-in freezer directly into a smoke-filled sauna.
That is exactly what it feels like. And if we connect this to the bigger picture, it all comes back to that high-pressure ridge acting like a physical lid.
On the Central Valley.
Exactly. The Central Valley is basically a massive flat bowl surrounded by mountains. Usually, warm air rises. But because of the high pressure, we have sinking, compressing air pushing down from above.
And that traps everything.
Right, that is the inversion. The warm air aloft acts as a heavy blanket, so the heat and the wildfire smoke get pulled into the valley basin, and the air physically cannot rise to clear itself out.
While on the coast, San Francisco is completely insulated by that dense, cold ocean air.
Because the mountains act as a literal dam, keeping that cold marine layer locked over the bay.
Wow. So the West Coast is dealing with this brutal combo of dry heat and trapped smoke. But moving east brings a completely different and honestly, much wetter kind of misery.
Oh yeah, the southern squeeze.
Right. Because Texas is just locked into dangerous heat. Dallas is at 99 degrees. Austin is at 101.
And Houston is 97. But with the Gulf humidity, the heat index is being pushed well above 105 degrees.
Yeah, and New Orleans and Baton Rouge sit at 91 degrees, funneling Gulf moisture northward with daily storms. But I have to push back a little here.
Go for it.
99 degrees in Dallas in August sounds pretty standard for Texas, like it's Texas in the summer. Why is the AccuWeather monthly forecast for Dallas being framed as such a dangerous story?
Well, the critical distinction here is the duration. You have to look at the difference between a brief temperature spike and a sustained heat event.
Ah, so it's the fact that it doesn't break.
Exactly. Hitting 100 degrees in Dallas in August is totally normal. But usually a frontal system moves through, you get a solid thunderstorm, and temperatures drop back to the low 90s for a few days. The infrastructure gets a break.
But that's not happening this time.
No. AccuWeather's monthly forecast is showing daily highs from the upper 90s to 103 degrees throughout all of August. Unbroken, month-long duration.
Oh, wow. So the asphalt never really cools down.
Right, and the electrical grid is under maximum load continuously. Plus, when you factor in places like Houston or New Orleans, the true danger lies in the lethal heat indices generated by that Gulf humidity.
Right, because of the dew points.
Exactly. When the dew point climbs into the mid-70s, the air is holding so much water vapor that evaporative cooling completely shuts down.
Because your sweat just sits on your skin.
Right, so even if it says 97 degrees, your body experiences it as 105 or higher because you're actively trapped in your own body heat.
That is just miserable. And all that saturated Gulf moisture doesn't just sit in the south, right? It's being funneled up the eastern seaboard.
It acts as the exact fuel needed for violent afternoon weather.
Which brings us to the East Coast conduction. If you look at the I-95 corridor today, it is just loaded.
It's incredibly humid.
Yeah. NYC and Newark are at 90 degrees with little overnight relief. Washington, D.C. and Philadelphia are hitting 91 degrees with dew points heavily in the low to mid-70s.
The air feels like a wet wool blanket.
It really does. And this daytime heating is combining with a weak shortwave to trigger convective storms that carry serious damaging wind threats. I always think of the atmosphere along the East Coast on days like this as a violently shaken soda can.
I like that analogy. It's highly accurate.
Because the morning feels deceptively calm, you know?
Yeah.
It's muggy, but quiet. But the daytime heating acts like someone is just shaking that can all morning.
Building up immense pressure.
Right. And then the shortwave acts like someone finally popping the tab.
Exactly. A shortwave brings a fast-moving ripple of slightly cooler air in the upper levels of the atmosphere. And when it removes the cap of warm air, the massive buildup of hot, humid surface air violently accelerates upward.
Which causes explosive afternoon thunderstorms.
With massive downdrafts of wind, yeah.
And we see a very similar mechanism down in Florida, right? Though driven by a different trigger.
Yeah, Florida has its own unique setup.
Because they are locked in their daily sea breeze convection cycle today. Orlando is 92 degrees, Tampa is 91.
The mechanics there are fascinating because Florida is just a peninsula surrounded by water. As the sun heats the land, the air rises rapidly.
And nature abhors a vacuum.
Exactly. So the cooler marine air from both the Atlantic and the Gulf rushes inland to replace it,
Crashing directly into each other right over the interior.
often right over Orlando. That physical collision forces the air violently upward, triggering daily massive storms like clockwork.
Which is wild.
It is. And this raises an important question for the East Coast overall. How do millions of travelers and commuters adapt to a reality where there is a daily, entirely predictable threat of damaging afternoon winds?
It's a logistical nightmare, really. If you are driving the I-95 corridor today, understanding this shaken soda can affect is absolute crucial.
You really don't want to be caught in those downdrafts.
No, you have to time your travel to avoid the worst wind gusts when that shortwave hits. Though there is one exception on the East Coast today. Charlotte and Raleigh are drier, which matches NOAA's monthly outlook for the Carolinas.
Yeah, they managed to dodge the worst of that moisture funnel today.
So what does this all mean? If we zoom out, the nation is currently divided into these distinct zones of atmospheric stress.
Very distinct.
We've got the western heat and smoke dome, the southern humidity pump, and the eastern convective squeeze, with only the Midwest like Chicago at 81 degrees catching a slight break.
They are definitely in the one stable pocket right now. But looking at the sheer scale of the extremes everywhere else, it really forces you to step back and look at the future.
How so?
Well, if AccuWeather's sustained heat events, where Dallas can't cool its infrastructure for a month straight and Phoenix's complete lack of overnight cooling represent our new baseline for August, how long before we have to fundamentally redesign our urban lives?
Wait, really? Redesign completely?
Yeah, I mean, will our homes, our electrical grids, or even our standard 9 to 5 working hours need to completely shift to a nocturnal schedule just to survive the summers of the future?
Oh, wow. Just moving construction, commuting, running errands all to the middle of the night.
Simply because the daytime sun becomes a lethal, unworkable reality.
That is a staggering thought to mull over. Just a completely nocturnal shift to exist in the summer. It really puts the immense scale of this stressed planetary engine into perspective.
It absolutely does.
Well, to everyone listening, whether you are traveling under the heat dome, checking in on family dealing with the southern humidity, or timing your commute around those explosive East Coast storms, stay cool, keep an eye on the sky, and thank you for joining us on this deep dive.